Take it away.
Okay, yeah, hi everyone. Yeah, I'm Jason Williams from Bloomberg, and we're going to revisit the discussion we've had on container timing. We've also called it element timing for containers. Yeah, just in case not everyone was around or everyone was here before, I'm just going to give a quick recap of sort of where we got up to. There's been quite a bit of research since last time as well. I think it was February last month. So yeah, I'll try and bring you up to speed. Yeah, as you know, we have had issues raised with element timing. There's also issues raised with largest contentful paint, not being flexible enough to choose something larger like a component, mainly because LCP is built on top of element timing, but this API is quite limited in that it just supports singular elements, mainly just text nodes and images. You couldn't set this on a div, for example. And yeah, not just in the web, but this affects us too. I showed this last time. This is a Bloomberg terminal. This uses Chromium for its rendering, and this is one of our benchmark functions. And we use largest contentful paint on this because it is just Chromium under the hood. We like to use these metrics for our own applications. And then in this example here, we get the small title in the corner as our candidate, even though for us and our clients, the table with the data is the main piece of content for us that we want to know as painted, and that's what we want to mark. This is courtesy of Andy, but basically it's the same in the web. More and more of the web is becoming component-based, and performance should be no different. Developers want to know when a widget or a component or even a subsection of the DOM has been painted. And that's, yeah, pretty much the question that we've been trying to ask when we've been doing this. How can you know when a container is painted? It's not too easy to do, mainly because the browser isn't aware of any future updates, dynamic content, or swapped out elements, or maybe images being Ajaxed in. So there's a few things we probably think we shouldn't do. Probably don't think we should pick some sort of arbitrary size. I think the requirements for this threshold could change per user. I think it would be too tricky to pick. I think the same with choosing percentage based on a percentage of painted content. I think that is also going to be tricky to decide on what sort of threshold we would have. I think even if developers passed in some sort of percentage, I think that'll be tricky for us to maintain. What we were looking at is something more like LCP, a bit of a candidate model. So updating the container with a summary of data as things are changing within that container. So as it's painting, as it has more and more elements, sort of updating the user on the latest sort of paints happening. Preferably the user can just pick the most recent entry that has all the data in there, and hopefully the times in that are more accurate to what they want. So that's sort of the idea that we've been working towards, and trying to take that idea and put it into a proof of concept. So we created a polyfill after the feedback from the first meeting we had, and we called it container timing. The idea is it provides an API. It allows monitoring of various containers that you can select, and it will essentially give you data back as the container's painting. So just a real quick mental model of how this works. If you imagine you've got your component, which is just made up of various DOM elements, you can attach a container timing attribute to that. When the polyfill kicks in, it will annotate all of the leaf nodes or the contentful nodes, images, paragraphs, etc., with element timing. If there are any sort of transitive divs in the middle, they get ignored. But we basically traverse the whole tree of that component, and then we subscribe to a performance observer, and then we sort of listen back for any events that come through, aggregate those, and then we give you sort of aggregated sort of entry of data back. These are usually batch, so we don't normally have, we try not to give an entry for each individual element. So yeah, I've got some examples to show you. This method that I just talked about, it gives us a lot of data to play around with. How do we sort of interpret these useful metrics? What do we do with it? Like, what do we show the developer? We try to start with the most naive approach, and then we try to get a bit more intelligent as it goes on. So what I'm going to show you now is sort of maybe the most easiest solution, the most simplest way, and then we sort of added onto it. So the first one I'm going to show you is a similar table made in HTML for the web, and we're just going to use a callback that has render times, container timing. So I don't know if you can see this very well. I've got DevTools open. I have a table that's loaded. In this table, column 2 is not been filled out. We have a sort of AJAX request. Column 2 gets populated. We have a second render time, and one of the cells also got swapped out. So the div of that cell swapped. So that was the bottom of cell 6. So we get three. We basically get 3 events, and for each of those events, we get a render time as data happens. So in this case, there was new content added that triggered a new entry, and at the bottom of column 6, we also had a node that was swapped out. So because that new node had element timing, that triggered a new entry as well. This works. It's not great. We do get render times of updates. There's not much data there. We can't really look at that to see which one of those was the most useful, or is it finished? Is everything there that we need? Also, elements that are swapped out, I'm not sure if that should really count as a new paint because there was content there before. So what we did is we tried to, one of the feedback that we had was to look at sort of the intersection rect of these elements to see if we can sort of match up the size to sort of calculate. Maybe we can do something with size to work out how much of the container there is and give that back to the user. So in the next example, I'm going to show you the same one, but there's a green overlay. So this is the polyfill in debug mode. And the green overlay is just to show you the rectangle, the bounding rectangle that it takes into account. So here we go. So same again. What we see happening here is the first paint, we have render time, we have an identifier, and we have a size. Similar to what I was saying earlier with size, it's a bit of an issue because in this example, column 2 hadn't painted yet, but the green overlay sort of covered column 2. So the problem that we have is it's covering areas that aren't even painted. So it's quite a misleading value to give back. So that's one problem. And also, if you notice in DevTools at the bottom, you see that the size is actually the same. The size is the same all the way through because the first paint we had covered the majority of the container. So when column 2 comes in, there's no difference. So that's one issue. And also the bottom of column 6 repainting, having the elements swapped out also triggered a new entry. It's a bit better than the first one. We do get a bit more information, but we get a misleading size. And if there's any element swapped out, that's triggering a new entry also. So we had a bit of a think about this. We thought, can we do any better? And we had some new ideas. We decided that instead of focusing on creating a bounding rect that covers all of the elements that have been painted, to think about focusing on areas that haven't been painted yet, and then only triggering when there's a new area in that container painted. So we call this visually complete. And we decided to try keeping track of all of the elements and the intersection rect that they have for the coordinates, where they've been painted, and only if something is painted in a new space of that container, we will trigger an entry. So you're going to see the green overlay again, but it's going to be a lot more granular in this example. So here, just refreshing. Yeah, so here, you see now we're just covering the elements themselves. We still get a new update for the dynamic content that came into column 2, but there is no third entry because where the bottom cell was on column 6 that went red, that area was already painted, so we don't count that as an updated entry. So we're just counting new painted areas. So for us, we get render times with updates. I should mention as well that the size is much more improved. It actually will always increase, similar to the largest contentful paint. The size should only ever get bigger as we take into account new areas. So the size is a bit more accurate now than what we had in the second example. We actually see 95,000, and then we see that increase to 127. So yeah, we get better rendering times with updates. We get more data in the container. We get a much better size that more represents what we're actually seeing on the screen. Any areas out or repainting that are the same area, we're not re-triggering an entry for that. So this is much better. And we thought, well, there's a lot of data that we can get from this. What do we want to show? So this is, if we look at the container as a subsection of the DOM, they can give their own scoped metrics. So it doesn't have to just be like a visually complete paint. We can also surface largest contentful paint from within this container. We can surface first contentful paint. There's many things that we could offer to the user from this. So this is just an illustration, just as a talking point. But it'd be good to hear from people what they're interested in. I want to touch on nested containers because this was brought up before. I think it was Ian Selland who brought this up as a question. Yeah, we took a look at this. I think this is a really good question, and we wanted to see how we could deal with nested containers. What I've done is I've offered 3 modes. We don't obviously have to go down using all 3, but here's the sort of 3 modes that you can do in the polyfill today. The first one is ignore. So if you was to have container timing twice, one component wrapping another, one option is to completely ignore entries coming out of the inner container. So both containers run in isolation. You can register interest in one or the other, but the wrapper would not receive any events from elements happening in the inner container. So any sort of painting, any new paint events would not bubble up at all. So in this case, the inner container is completely grayed out. There's transparent. So this would be like not seeing a boundary at all. The wrapper container would receive updates on any elements painted. So if there's a largest contentful paint in the inner container, it would also bubble up to the wrapper if it's bigger than anything the wrapper has. This does mean you'll get duplicate because both inner and wrapper would get there'd be 2 entries for both, but this could be useful for some. And finally, the shadowed. This was inspired by the how do we deal with shadow DOM thread on the element timing repo. This is very similar to transparent, but the pieces of data around elements and size would be scoped just to the container host. So you wouldn't have information on any individual elements. This might be useful if we start to cover shadow DOM. Shadow DOM could essentially do something like this, where we only ever see the size or element referencing the container itself. Yeah, so performance impact, what I did, one of the feedback from Yoav last time was to take a look at enabling element timing everywhere on a build of Chromium to see what the impact would be. So you can also follow this on the repo. There's quite a bit more data on there. Yeah, I basically did the build of Chromium where all elements were sort of registered for element timing, even if they didn't have the attribute, and did a bit of comparison for that. So there's more of the methodology on the link if you want to see. Yeah, so what I did is I did a build that was just a fresh build with no changes, and then a build which registers all elements, text and images into element timing, and then ran speedometer 3. The changes aren't huge. I think we've had some offline chats about this. We weren't really expecting to see big changes on the overall score. I also checked the React Complex DOM test. I believe that was a good one to check as it generates 6,000 elements. And you can see that there is a bit of performance penalty on that one. Obviously, this is the worst case because this is enabling all elements, but we believe that if we were to natively implement this, it wouldn't be that bad. Looked at memory also. Memory usage on some of the top 20 websites. Didn't change too much. This, I think, was also expected. The entries aren't too big. There's also a cap in the buffer of entries. They also need to be in the viewport. And I think the reason why we don't see too much change overall is there's a lot of instrumentation happening on these elements anyway for other metrics like LCP. So limitations. Yeah, the polyfill does need to load as early as possible. It needs to be preferably in the head because we need to mark elements before they're painted, essentially, so that we do get the element timing performance entry. This means we need to manipulate the DOM on page load as soon as possible. We need to run a mutation observer to listen out for new elements coming in. We could mitigate that somewhat by maybe having some interaction happening which cancels the mutation observer, but that still needs to run as early as possible. And yeah, I think there's some good things that have come out of this. We do think visually complete will help us a lot with the last example I gave. That is what we're trying to achieve. But the implementation we have, we don't really feel too confident with putting that into production. I think the polyfill alone could slow down rendering. There's a lot of moving parts to maintain, and we would want some more stability in this. And I think some other developers would feel the same. We try to look at solutions. So Bloomberg has a partnership with Igalia to contribute work upstream and to the web platform. We are quite interested in helping out more in the performance space. So we've had conversations with Igalia and some of the engineers there. They've been taking a look at this, and they feel that they could develop a much more optimized version. There's a lot of optimizations left on the table around element timing. For instance, one idea is to add a bit field to lay out object bit fields to store if the node does have container timing does have a container timing query on it, or if its parent does, so we don't have to traverse as much. I've been talking to Yoav. I think there's a similar technique that soft navigation has for this, so maybe there's something we can do there. But essentially, before we generate the overall DOM and the tree, we could probably add some markers to elements so that we don't have to have every single element being checked and traversed. Yeah, so finally, questions. What do implementers think about adding container timing? Or maybe there's just parts of container timing that work natively. Maybe some of this stays in the library like Web Vitals. Maybe something like Visually Complete is in Web Vitals, and we have some of the inner workings in natively. What is the working group's thoughts on the Visually Complete idea, which was the last example we had? Has anything like that been tried before? And yeah, like what sort of data would the working group like to see if they were to use an API like this? And that is it.
Let me just stop the recording and we can discuss.